Good evening, all. How are you? How are you this week?
All good.
I've received few assignments, but not all. And few have, you have shared in Word document. So please share it in PDF document, okay? Like a non-editable document. Yeah. So today, mostly we will cover into VPC. Okay. In the last session, we have seen about a compute service, which is EC2. And we also discussed about Lambda, how it is different from EC2. A deep dive into the EC2 features. And we also understood the storage services, like we have EBS, EFS, and S3. And we have explicitly seen how they are different from each other. Okay. Now, because in the last week we spoke about data, I also want to discuss about another service regarding the data, which is like what if you want to move your data from on-prem to the cloud? Okay, like a data migration. Yeah. So we will see about the migration services now for a few minutes. And then I'll start with the VPC, which is one of the core service in AWS. Okay. But before I start with the migration services, I would like to check if you have any questions regarding to the previous session or anything which you want to ask me. Okay, so looks like everything is fine. Now I think I can start with today's session, and I'll share my screen. Now let's talk about the migration services. Now, when we say data, for example, I have 10 GB of data. I wanted to move to cloud. Like S3 is a service where we can just store huge amount of data, and each S3 bucket in AWS supports unlimited capacity. Correct? Now, if I want to store some 10 GB of data into S3 bucket, I can simply upload those files into S3 bucket. If I have some hundreds of GB, it is difficult, but I can still try to do it. It will take some time. But if you want to store terabytes of data, exabytes, petabytes of data, then you can still do through internet, but it will take weeks, months, or years also sometimes, depending upon the data which you are moving to cloud through internet. That's where we have data migration services. We not only have a data migration, if you want to migrate your data, if you want to migrate your database, we still have the services in AWS accordingly. Okay, so we explicitly talk about data and database now. We also have application migration services, VM migration services, etc. We will not touch upon those things, but yes, I would like you to know that that there are services like where we can export a virtual machine or an application explicitly, okay, or with a virtualization layer as well. Yeah. Now, first thing which I want you to understand is about the migration hub. So migration hub is not any migration service. It is just an interface where you can see all the migrations happening in your AWS account. I have 10 regions, and there are some 10 migrations are happening in my account. So I can just monitor them from one place, which is a migration hub. It's basically a single place where you can monitor the migrations. Okay, so there is no cost to use this AWS migration hub. You will be paying only for the migrations. Just to monitor, there is no cost using this migration hub. Okay, So it will actually show you how to, how the things are moving from on-prem to the cloud, the status of each of the migration steps. Okay, and this also allows you to track the status of all moving parts across migrations, where it will allow us to see the overall migration process. So this is about the migration hub. Now let's move to the database migration. Now let's assume that I have an MySQL in on-premises, a MySQL database in on-premises. Now I want to move to cloud. So one way is where you can take a backup of the database and then you move that file to the cloud. From that, you can spin a database. Yes, you can still do all those things. But if you want to go for the live migrations, where your database is still running, and then if I just wanted to migrate, what you can do is you can go for database migration service in AWS. Okay, where it will help us to migrate from on-prem to the cloud. So you just have to say what is the target, what is the source. So that means let's assume that in on-premises, you have MySQL database, which has some sort of data using by the application. Now you want to move that to cloud. Means migrate. Okay. So if you are looking for the same database in the cloud also, AWS can possibly can migrate it. But if you want to go for, so this is your source database and this is your target. Okay. So if you want the same database to be in the cloud, means in the cloud, in a server, the MySQL database engine will be installed and then your data would be migrated. Okay, so if you're migrating from MySQL to MySQL, it's basically a homogeneous migration. It's a homogeneous migration, but you have your MySQL in on-prem, but you want to migrate to Oracle. Maybe you want to use a different database. So AWS supports even that. Okay, so this kind of database migration is called a heterogeneous migration. So MySQL to MySQL is homogeneous, MySQL to Oracle is heterogeneous. That means if you have two different databases, it will have different schemas. Okay, then you may need to go for heterogeneous migration. Okay, so there will be a schema conversion tool where it will convert that schema. Okay, this tool will convert the schema from MySQL to Oracle before it moves the data to it. Okay, so coming to the benefits, it's simple, minimal downtime, supports wide list databases, low cost, fast and easy to set up, and reliable. That's about the database migration service. Next, we have Snow Family. So Snow Family is basically about data migration. So whatever we have seen just before, the previous slide is about database migration. Now, what if I have lots of data in my on-premises and I want to move to cloud? Okay, so it all depends how much data you have it. So you have less data, then you can go for the appliance which is related to that. Okay, so let me show you with an example. So first of all, let's assume that you want to have migrate some 50 to 100 terabytes of data to cloud. Initially, you have to create a job in the AWS Management Console. Okay, so when I say data migration, I'm talking about the offline transfer, not online, because if you want to transfer through internet, it will take, as I said, years or months. Okay, so if you want to go for Snow Family or if you want to use an offline mode, you can go for you can just go to the AWS Management Console and you create a job and asking for a hardware appliance. So what AWS will do, AWS will deliver you a physical hardware appliance. So this is like, it looks like a suitcase, okay? It looks like a suitcase where it is basically a hardware appliance, yeah, where it will be delivered to the client location. Let's assume that I want to migrate to cloud. So I will create a job. This hardware appliance will be delivered to my data center. where this is basically a hardware appliance, a physical one, where I'll take this hardware appliance and I will connect it to this hardware appliance with a wire, okay, I'll transfer the data using the supported protocols. Once the whole data is transferred, a local carrier on behalf of AWS will pick up this Snowball device, and they will move to S3 bucket. Okay. Once the data is completely migrated to S3 bucket, the data which is in this device will be erased so that it can be used for other customers. Okay. And there is also a notification service where I will be getting some sort of notifications whenever a data was moved to, or it is in transit. So it's like a status. You will be getting a notifications as well. Okay. So what kind of hardware appliance to be used depending upon how much data you want to migrate it. For example, if it is in terabytes up to 50, 80 or 50 to 100, then you can go for Snowball. Okay. And these hardware appliance is secure. So these hardware appliance is having a multiple layers of security. So it is designed to protect your data, including tamper-resistant enclosures. The encryption is there. They're using different kinds of algorithms to secure the data. Okay, with both security and full chain of custody of your data. Okay, and once the data transfer is done, AWS performs a software erasure. Yeah. Now this device, a Snowball, this Snowball device is supports with 50 to 100 terabytes in all regions and 50 to 80 in US regions. Okay. And coming to the benefits, high speed and extremely scalable, tamper resistant and secure, simple and compatible, and easy data retrieval. Now coming to the use cases, it can be used for cloud migrations. If you want to migrate huge amount of data, for disaster recovery, where I wanted to transfer the data to cloud as soon as possible because there is an a disaster is going to happen or it's happening. So I just want to recover how much ever data I wanted. I can. Okay. So for that, you can actually go for a Snowball, or you can also go for content distribution. Maybe you want to transfer, for example, if you want to transfer some sort of data to on-prem to the cloud, yes, it is possible. It is also possible to send from AWS to your customers. So let's assume this is my company. Okay, my on-premises data centers. I have moved to cloud using Snowball. Okay, now that I wanted to move some sort of data to my customers, means my client. So I can also move the data from AWS cloud to my customer locations. So that means vice versa is also possible. Not only from on-prem to the cloud, from cloud to on-premise is also possible. Okay, so maybe on a daily basis or a regular basis, I wanted to send a huge amount of data to my customers. That's my requirement. AWS can help you for that as well. Now, what if you want to transfer some petabytes, exabytes of data? Like if you want to decommission your data center and you have a huge data center where it has tons of data. So maybe Snowball device will become very small. The Snowball will be very small. It supports some terabytes. But what if you have exabytes, petabytes of data? So instead of ordering multiple Snowball devices, you can go for Snowmobile. So this Snowmobile basically supports 100 petabytes of data. Okay, so whenever you create a job for Snowmobile, of course, it's very expensive because there will be a physical truck which will be delivered to your data center, where up to it is equivalent to 1250 Snowball devices. Okay, and it's a 45-foot long ruggedized shipping container, and it is ideal for multi-petabytes or exabytes digital media migrations and data center shutdowns. Okay. Now, as usual, whenever you create a job, it will just park into your data centers. You connect it with supported protocols, transfer all the data, and it will be driven back to the AWS regions, and it will be transferred to S3. Very simple. And this Snow Mobile is also tamper resistant, waterproof, temperature controlled, with multiple layers of logical and physical security, including encryption, fire suppression, dedicated security personnel, GPS tracking, alarm monitoring, 24/7 video surveillance, and an escort security vehicle during the transit. Okay, and this Snow Mobile is available in all AWS regions. Now, coming to the key features, fast data transfer when compared to online, strong encryption, rugged, durable, and secure, customized for your needs, and massively scalable. And use cases, it is used for data center decommission. So yes, there are many steps involved in decommissioning a data center, because see, when you say decommissioning your data center, that means you are no longer using your data center. Going forward, you will be using cloud. So if that is the case, you should be making sure that all the data is transferred from your on-premises to the cloud. Okay, so once you confirm that all the data is moved to the cloud, then you are okay to decommission your data centers. Okay, there is also another data migration tool like Snowcone. Okay, so it's not there in the presentation. I'll show you data migration. So there is another one which is Snowcone, which is a smaller one where it supports. Yeah, Snowcone. The smallest number of if you want to transfer some 20 terabytes or so, I'm just looking into the features. If you can see here, so Snowcone is available in both hard disk, HDD and SSD. Okay, and the Snowcone HDD has 8 TB of usable storage, while SSD has 14 TB. So this looks very small. Okay, I'll show you the image also. AWS Snowcone. Like it looks like a hard disk, a bigger hard disk, you know. So this is like a Snowcone, AWS Snowcone, a smaller one. Okay, so where it supports, as I said, 8 terabyte to 14 terabyte, depending upon HDD or SSD. And we also have, I'll also show you Snowball. We have seen Snow Mobile, right? It's like a truck. Snowball will look like a suitcase. Little big. Obviously, it supports some 100 terabyte, no? So this is like a Snowball. Okay. And Snow Mobile, I have already shown you, but let me. It's like a truck. Okay. So when you say data migration, we do have 3 options: Snowcone, Snowball, and Snow Mobile. Okay. Yeah. So offline data transfers, these 3. I can share this link to you. So that's about the migration services. Any questions, please?
Yeah,
a simple topic which I actually wanted to talk about it when I'm talking about data only. Okay. Yes, please ask.
Yeah, I am Srikanth here. So actually, you already told, right, from on-premise to cloud. So if you are using some services in on-premise and some services in cloud, so if you want to connect both on-premise and cloud, so there is some connector will be there between you can say cloud and on-premise systems. So in Amazon, what is the connector? That one?
What is it? Factor.
Connector, cloud connector.
Connector. So you can use VPN. There is a VPN supported in AWS. There is another tool which is called Direct Connect. So you
Okay.
can use either of this to connect from on-premises to the cloud.
Okay. Okay.
Okay, so we will see that about it in the slides of VPC probably tomorrow.
Okay. Okay. Okay.
Yeah.
Madam, you said spinning the database. What does spinning of database mean in the cloud?
What is that?
Madam, you said like for migration of database. So like once it's moved to the cloud, you spin the database. I don't know what spinning of database.
Spinning means creating it. See, I spin an EC2 instance. Means creating it. Yeah, it's just another way of saying it. That's it.
Thank
you. Yeah. Any other questions? Okay. So, I want you to concentrate well on this VPC topic. Okay. So when you say we are an architects, okay. So understanding about VPC is mandate. Yeah. Let's understand what exactly is that. It's one of the core service, as I said. And my explanation itself about VPC will take almost 1.5 hours. Depending upon your questions, it may touch 2 hours also. And we will also do the hands-on on VPC, and I'll give you time for you to do it in the class. So today, apart from the data migration, the whole class is all about from now is about VPC. Okay. So I want you to concentrate well. Okay. Please don't get lost somewhere and then you ask me from the beginning. It's not possible because it is like a flow. Okay. So I'm just saying it beforehand so that you can start concentrating. Yeah. Now, VPC, which stands for Virtual Private Cloud, it's like a network. Okay. Let's assume if you're working in an organization, the laptop or the desktop which is dedicated to you will be in an organization network, will be a part of your network. So what is a network? It's a collection of machines connected together. Okay. So collection of IP addresses. Each IP address will be assigned to a machine. So it's a collection of machines. So any organization, if you see any organization will have their own kind of network so that they will control. Okay, as I said, if you have your, if you're working in an organization, the laptop or the desktop which is given to you will be in an organization network where they can control what you can and you cannot access, right? So that can be controlled through a network. So like there is a network in on-premises, we can also create our own private network in the cloud also. So the service for that is VPC, as simple as that. Okay, so we can also create our own network virtually in the cloud. That is, it's called a virtual one, but it's a private network. Okay, so VPC stands for Virtual Private Cloud. Now, when you create an AWS account, so we have created in the first day, right? So when we create an AWS account, AWS creates a VPC by default in every region. Yes. So by default, it is created when you create an AWS account in every region. And whatever the hands-on which we have done so far, we did it in the default VPC, that VPC only, the VPC which AWS has created. Okay, so whatever the components which AWS creates, that components are called the default components. So the VPC which AWS creates is called the default VPC. Okay, now what we will do, we'll try to create a custom VPC in the cloud. Yeah. Now, in AWS, in North Virginia region, region will have availability zones, right? We can create a VPC. Okay, so we are creating a VPC in a region. Means VPC is region specific. Means VPC will span all the availability zones in a region. Okay, Now, when you are creating a VPC, we need to define a network ID. Okay, we need to define a network ID for this VPC. Now, like any other organization, even AWS follows some standards in order to create a network ID. Okay, so we cannot randomly create whatever the network ID we wanted. There are some standards which any organization will follow. Even AWS is doing the same. Okay, so AWS follows RFC 1918 standards. You can just explore about this if you wanted to know more about it. But what I'm trying to say is AWS VPC, AWS follows RFC 1918 standards in order to create a network ID where we can create any one of these CIDRs. Your VPC network ID can be something like this. Okay, so we can go for any one of these ranges. Okay, now before we actually assign this network ID to the VPC, let's understand what exactly is this. So what exactly is the CIDR, how it works, etc. Okay. Now, if I can exclude this /16, if I can just exclude this part, the /16 part, this looks like an IP address, right? Something like this, 17.2.3.4. It looks like an IP address, correct? And this IP address is basically an IPv4 address. It's a 4th version of the Internet Protocol. Okay, so it's an IPv4 address. And this IPv4 is a 32-bit long. Okay, this IPv4 address is divided into 4 octets. Now, this is an octet. Octet. Okay, so we have 4 octets. One octet is of 8 bits. We have 4 octets, 8 4s, 32-bit. So an IPv4 is a 32-bit long. Okay. Now, when I say an octet is of 8 bits, when you say bit, it can be either 0 or 1. So this is false, this is true. 0, 1. Okay. Now, when we say 8 bits, the value of an octet, this is basically in decimal, right? Now, when you say 8 bits of an octet, the value of an octet can be from all zeros to all ones. So 8 bits, no, 1, 2, 3, 4, 5, 6, 7, 8 zeros to 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so the octet in decimal, when it converted into binary, it can be from all zeros to 8 zeros to 8 ones. Now, when you say 0, 0 value is 0 only, right? So when you just say 0, the value in decimal is again 0. But when you say 1, the 1 in each position has a value in decimal. Means, so when you take 1, 2, 3, 4, 5, 6, 7, 8. So this is in binary, right? Now, when it comes to decimal, okay, when it comes to decimal, the 1 in the rightmost value in decimal is 2 power 0. Means it's 1. This is 2 power 1, which is 2. This is 2 square, which is 4. So it is just a multiplication of 2. 1 multiplied by 2, 2 multiplied by 2 again, 4 multiplied by 2, 16, 32, 64, 128. So this is 2 power 7, 6, 5, 4, 3, 2, 1, 0. Okay. So the 1 in each position has a value in decimal. Now, if I add up all these numbers, I would be getting 255. So a value of an octet can be from all zeros to all ones. In binary means 0 to 255 in decimal. Okay, so you take any IP address in the world, any IPv4 address in the world, an octet. Okay, any octet, we have 4 octets, right? An octet will be in between 0 to 255. You never see an IP address which is greater than 255, which is less than 0. Okay. Now, when I say a 17.2.3.17.2.3.4, okay. Now, if I convert that into a binary, so 17 is a decimal value, right? So 17 is a decimal value. Let's convert it to binary. Now, if I want to convert into binary, I need to have this table, this one. Okay. Now, you just need to check what numbers to add to make 17. If I add 16 plus 1, it makes 17. So I will keep 1 below 16, below 1, and remaining I'll keep it as 0. So we know that a value of an octet can be from either 0 or 1s. If the decimal value is 17, the binary representation of the 17 is this. Okay, so if I wanted to make it as 17 in decimal, like 16 plus 1, I need to keep 1 and 1 in binary, and remaining will all be zeros. But for what about 2? So just below 2, I need to keep it 1, and remaining all are zeros. But what if I want to make 200? So now you need to start adding the numbers. So 128 is less than 200. So I can straight away keep 1 here. And you just need to try to add 128 plus 64. 192. That means I can still keep this 1 as well. But I still need 8 to make it 200. So I can straight away keep this 8, the below position, as 1, and I'll keep remaining all of 0. So that's how we actually convert from decimal to binary. Okay, so I also want you to give me some binary representation, okay, for few numbers, so that I can understand that you understood this concept. Okay, for example, for 150. So what is a binary representation of 150?
You need to keep.
Sorry?
128, 1.
Can you keep it in the chat? If I don't, I couldn't hear you. Maybe my volume is full. So 101. Someone is saying 101, and remaining all are zeros. Okay. So 101 means 128. And
That's
160.
160.
32.
That's 160.
That's 160. Yeah.
Yes, it's 160.
That is the number for 160.
Yeah, that's not correct. So then what is the right number? Can someone tell me?
1001.
1001.
0
0
1 double 0
1
double 0.
double 0. Okay, let me add. So 128 plus 16 make 14, 2, 3, 4, 144, and I just need 6. 148, no? It's
Also-
not 150. Am I
It's
missing
one,
something?
I mean, yeah, 2 also you need to add it.
Madam, it's
More. 110.
110010110.
Hmm. Yeah. Okay. So let me give you a few more numbers, okay?
Sure.
I'm just trying to keep this table, so I'm just erasing the other ones, okay?
Okay.
So that you can see the table and then you can make some choices. So how about if I go for 1 3.
Okay. Can I tell you?
Can I have the binary representation in the chat?
Okay, fine.
So it's 0. Okay, I'm getting different answers. 1 1
Madam, 0111101.
Okay. Okay, I'm getting majority of these answers. So 64, 32 is 96. And then 16, 11 plus 1, 113. Perfect. Now, what if I want to go for 95? What is a binary representation of 95? So 0, 1, 0, 1, 1, 1, 1. Oh, oh.
All ones.
Yes, that's correct.
Okay, let me try. So 64, 1, 1, 1. Okay, fine. So 2 plus 3, 2 plus 1, 3, 3 plus 4, 7, 7 plus 8, 15, 15, 16. So
31.
31. So let me add that to it. So 95. Perfect. Perfect. So Srikanth, I think you're making some different answers. I mean, even for the last time, I have seen some different answer. Yeah. So please cross check. Okay. I want that the reason why I'm giving different examples is that just I want you to practice few examples and need to know. Okay. Now, for 257, what is the binary representation of 257?
It should be 255, right?
It
Louder,
should be below
please.
255, right?
It should be 250.
So it's a wrong answer. It's a wrong answer.
Hmm.
Okay, so you should be able to make that.
Yep.
Okay, so there will be no octet which is beyond 255. Now, what is the binary representation of 255?
It should be all ones.
All ones. Exactly. What is the binary representation of 0?
It should be all zeros.
All zeros. Okay, perfect. Perfect. Cool. Now, let's go back to our actual topic. which is 10.0.0.0/16. Okay. Now when I say /16 now that we understood, this looks like an IP address, and this IP address is of 4 octets, and each octet is of 8 bits. It can from 0 to 255. Yes. Now when I say /16, this /16 represents the first 16 bits. So 8, 8, 8, 8. So the first 16 bits in the network ID. So when I say the first 16 bits, 8 plus 8, 16. And this represents a network prefix. Okay, so when we say /16, this is representing the network prefix in the network. Means network prefix. This network IP addresses will start with 10.0. That means all the machines within this network, within this VPC, will have or will start with 10.0. This will not change. So this is representing the network. Now, just by seeing an IP address, in the network, we can find, okay, what's the network ID? Okay, so 10.0 is a network prefix. This will not change. Okay, and the other 2 is for hosting. Means this can change. So this octet can go from 0 to 255. Even this can go from 0 to 255. Okay, so when you say the /16, this is representing the first 16 bits in the network ID as network prefix. And the remaining bits for hosting. Means this value can go from 0 to 255, and even this can go from 0 to 255. Now let's try to write the combinations of it, okay? Now 10.0 is fixed. Yes, we just learned that. Now when you say this can go for hosting, 0.0, 0.1, 0.2, so on and so forth, 0.255. 10.0.1.0 now. Now in the 0 series, we have completed from 0 to 255. Now one series, 1.0, 1.1, 1.2, so and so forth, 1.255. The same way, 10.0.2.0, 2.1, 2.2, so and so forth, 2.255. Now, if you see here, in each part, so you can go from 0 series, 0 to 255. 1 series, 0 to 255. 2 series, 0 to 255. So 0, 1, 2, so and so forth. We can go from 10.0.255.0, 255.1, 255.2, 255.255. Okay, now when you say /16, these can go from hosting, that means these 2 octets can go from 0 to 255. 0 to 255. Okay, now when you see this part, this explicitly this part, okay, now in this you have 0 to 255. Okay, that means how many IP addresses are there? From 0 to 255, how many IP addresses are there in this particular part?
256.
256. 256. Like that, I have how many parts?
256 parts.
Exactly. That means if I create a particular network with /16, I would be getting 65,000 plus IP addresses. I can have around these many machines in my network. So if you go for a bigger organization have a lot of servers. They will have a lot of machines who would be working on the servers. right? Now, according to the organization, they will go for the network. Okay, so if you create a network with this CIDR, you would be getting around 65,000 plus IP addresses. Now, when I say please go on mute. When I say /16, you need not go for /16 all the time. See, you may not need 65,000 plus IP addresses every time. Okay, so you need not go from 16 all the time. You can go from 16 to 28. You can go from 16, 17, 18, 19 till 28. For example, if I go for 28, that means the first 28 bits is for network prefix. Means 888, 83 is 24, 4 plus 4. Means I'm taking these 3 octets and also 4 bits in this octet. So where the first 28 bits will be for network prefix and I'll have only 4 bits for hosting. Means I'll get only, don't worry how I got it, we will get only 16 IP addresses. Okay, the more the number, the less the IP addresses we get it. So according to the number of servers which we need or the machines which we need, we actually choose the network ID, whether you want to go from 16 or 16 or till 28. Okay, so in AWS explicitly, I'm talking in AWS, you can go from /16 where you can start with 16 IP address and you can go till 65,000 plus IP addresses. Any questions? In whichever I explained for now.
So /16 would be the maximum limit, right? So 65,000 K plus IPs. Okay. The first network prefix, the first 2 digits, like those are like network prefix, can be fixed in any VPC. Is it like right to say?
No, right, Samarth? I just told from 16 to 28. If I choose 28, the first 2 digits are network prefix.
No. All are network prefix in that case. Only last 4 digits in the last octet would be for hosting, right?
4 bits, not digits. See, the
Sorry,
network
4
prefix,
bits.
network prefix depends on the CIDR, like the one which you choose, like /16 to 28, depends on what you have chosen. Simple.
Okay.
Madam,
Got it.
last part I didn't get that. The 28 one. So 8 plus 8 plus 8 plus 4 we are taken. Another 4 bits is for IP address. How in that 4 bits IP address of only 16 is formed?
I explicitly
That
told
I
you,
didn't
you
get.
need not worry about that venue. I didn't explain only you to understand. Okay,
Oh,
don't
okay.
worry about this. Okay, so where we will be getting 16 IP address, I don't want to go detail into it because I mean we are not learning networking here. Okay, we are just I'm just trying to simplify it so that I don't want to complicate to others who are completely new to networking. Okay, so this is how usually in networking the CIDRs would be created. Yeah, so I'm completely oversimplifying this topic so that I can go into my AWS service. Okay, just understand that if I go for /28, I would be getting the least as 16 IP addresses, maximum as 65,000 plus IP addresses. Okay, Venu?
Yeah, right. Okay.
One doubt regarding network prefix. So
Yes.
is it standard that it should start from 10.0 only, or?
No, we can go for any of these ranges. So if I go for 172 to this range, okay. Now when I say /16, here 172.16 would be network prefix. And again, I will be getting 65,000 plus IP addresses for hosting. Even in here, 192.168 would be the network prefix. Because this is 8 bits, this is 8 bits. So for I can start with /16, no? So 888888. So in whichever CIDR I take, these are basically called CIDRs, okay? A network ID or a CIDR, a classless interdomain range or routing. Okay, so in whichever CIDR you take, the first 2 octets would be network prefix if you take /16. So you can take any one of these 3. Okay, Srinidhi?
Got it. Thank you.
Mm. Okay, so now let's move to next part of this VPC. Now, once I create a VPC, in order to have my EC2 instances in that, I need to have to create, okay, subnets. Oh, shoot. I'm sorry, guys. Very bad at perfection. Okay, so let me create 2 subnets. One, I'll call it as public. I'll tell you why I'm calling it as a public subnet later. Just bear with me. Okay, for now, please understand that I am creating 2 subnets. One is one subnet with this CIDR, another one with this CIDR. Now let's understand what exactly are they. Okay, now for one subnet, I have given /24 with this CIDR. First of all, let's understand what exactly is subnet. Subnetwork. It's a part of the main network. So let's assume I have 100 machines and I have 4 departments. Okay. Now I need to distribute these machines to 4 departments equally. So what I will do, I will assign 25 machines to each department. Okay. So for example, if I have 100 IP addresses, basically like a network, a simple layman example, okay. 100 IP address as a network, I am creating 4 sub-networks, basically dividing my main network into different parts so that I can manage the permissions individually. Obviously, each department needs different permissions. Okay, so what I can do is instead of creating only one sub-network, I can create different sub-networks. Okay, like 4 sub-networks in this example, so that I can manage them easily instead of managing 100 altogether. Okay. So another thing is the subnets will be created depending upon like how you want to partition logically. So as I said, each subnet will be assigned to each department. So even in real time, maybe I want to create a subnet for application servers, another subnet for database servers. Okay, and another subnet for web servers. So yes, you can create different subnets. Okay, so now for now, what you need to understand is subnet is a part of your main network. Okay. Now, when I say 10.0.0.1.0 versus 24, so 10.0 is already a network prefix. Yes, it's already a network prefix. Now, when I say /24, that means 888, and this is the subnet ID. Combinedly, the subnetwork prefix. We know that all the machines within this network, okay, will start with 10.0 because this is a network prefix. On top of it, you explicitly logically dividing into a subnet, means you are dividing a part of dividing the whole network itself. Okay. Now, when I say /24, that means the whole 24 bits is for the subnetwork prefix, and this is for hosting. Okay, now when you say hosting, 10.0.1 is fixed for the subnetwork. So this is the subnetwork prefix, means this number will not change throughout this subnet. Means all the machines within this subnet will start with 10.0.1. This is subnetwork prefix. Okay, means all the machines will start with 10.0.1, .0, .1, .2, 255. Okay, so you will get how many IP addresses for this subnet?
256.
Exactly. 256 IP addresses. Okay. So don't you think this part is very same as this one? This one? 10.0.1.0, 10.0.1.1, 1.2, 1.255. So I have created this part as a subnet, simple. So likewise, I can create multiple subnets. So subnet is a part of main network. Okay. Now that we understood, if I create a subnet, I would be getting an IP addresses this way. But and I could also see that I will be getting 256 IP addresses. But in AWS, okay, this is only in AWS, okay? In AWS, for each and every subnet which you create in AWS, for each and every subnet, not just one, each and every subnet which we create, the first 4 and the last one would be reserved by AWS. The first 4 IP addresses and the last one would be reserved by AWS. These are the reserved IP addresses. Means AWS will reserve these IP addresses for some reason. We will see for what in the slides, okay? But now you need to understand that in each and every subnet, they explicitly saying what are the IP addresses also, okay? The first 4 and the last one will be reserved by AWS for some reason. That means the EC2 instances which you, the EC2 instances which you create in this subnet will not have any one of these IP addresses because it will be taken by AWS already. So even though you are seeing that you are getting 256 IP addresses, but you can use only 251 IP addresses. You have to keep it in mind, okay? What if you actually want 256 IP addresses? Can I go for this one? No, you cannot go. You have to go for a bigger range where you will get more IP addresses, not 256 exactly, because there are 5 reserved. Okay, so you have to keep this in mind because in interview they will be asking you about this reserved. Indirectly they will ask you. They will not directly, of course, they will not directly ask you anything. Okay, now this is the same with the second subnet also. Now in the subnet, 10.0 is again network prefix, and this is subnet work prefix. So The whole thing is subnetwork prefix, subnet ID, okay? And this is for hosting. Yeah, and again, this will go from 0 to 255, where there will be 5 reserved IP addresses, where you'll get only 251 IP addresses for this also. Now, these subnets should not overlap. Means, when I say overlapping, that means the IP addresses in this subnet should not be there in this subnet. Definitely it will not be there, because all the IP addresses in this subnet will start with 10.0.1. All the IP address in this subnet will start with 10.0.2. So are they overlapping? No, it's like this. Your passport number or your Aadhaar card or your phone number. You cannot, no one, like the number cannot be assigned to 2 people at the same time, right? There should be no duplicates, right? The same way, the IP address in one subnet cannot be there in another subnet. They should not overlap. They should be unique. Okay. Otherwise, when you're creating a VPC itself, it throws an error. Any questions in the subnet part? Now, now that, yes, we understood we can create a network and we can create a subnetwork, completely agree. But if I have my EC2 instances in here, what if I want to access the EC2 instances from the internet? I have to have an internet gateway. Okay. The internet gateway will provide the internet access for the VPC. Okay. The internet gateway, we have to be created and it has to be attached to the VPC. See, this is the VPC. It has to be attached to the VPC so that it will provide the internet access for the VPC components. Now, just by having an internet gateway to the VPC doesn't mean that all the EC2 instances will be able to talk to the internet. Okay, it has to be explicitly route under the route tables. That means now I'm talking about the justification of these terms, why I'm calling it as a public and private. Okay. Now, as I said, just by having an internet gateway to the VPC doesn't mean that all the instances within the subnets will be able to access to the internet. It has to be routed with the help of route table in order to make a subnet public or a private. Means in order to make instance to access to the internet or doesn't make, we have to route it with the help of route tables. Now, coming to the justification of these terms, if a subnet is associated with a route table. If a subnet is associated with a route table which has internet gateway as a route, then this subnet will become public subnet. If a subnet is associated with a route table which doesn't have internet gateway as a route like it has, okay, this subnet will become private subnet. Because this subnet is associated with a route table which is having access to the internet gateway, I am calling this route table as a public route table. Route table. Because it doesn't have internet gateway, I'm calling this as a private route table. Now again, if a subnet is associated with a route table which has internet gateway as a route, then this subnet is called a public subnet, so that the instances within this subnet will be able to access to the internet through internet gateway. See, I'm creating a path. And this instance will have a private IP address, can enable the public IP address. Obviously, without a public IP address, we cannot reach to the internet. We know, right? We have learned it in the EC2 slides in the last week. Okay, so we will enable the public IP address so that the instances within this subnet will be able to access to the internet through the internet gateway. In the same way, if a subnet is associated with a route table which doesn't have internet gateway as a route, then this subnet is called a private subnet, and the instances within this subnet will not be able to access to the internet because it doesn't have internet gateway. So this will have only private IP address, not public IP address, because it is not reaching through internet. Now, first of all, why I need to make an instance public and other one private by dividing with different route tables? Let's talk about this. Let's take you have an application, a Facebook application. Yeah, well known. We always talk about Facebook. I'll not change the example because everyone knows Facebook, right? I'll change the scenarios. I'll not change the example. Now, everyone is accessing the Facebook application through internet, facebook.com from a browser, right? Now, whenever you access and request some sort of data, the application will talk to the database. It will hit the database server, and then database server will respond something, and the application will respond to you. But do you have access to the database directly? No, because it is not that my data, everyone's data will be there in the database. I can access the application. I can access the data through the application, but not directly to the database. Means what? I need to keep this database private so that no one can access this database directly, only application can talk to it. And I want to make this application public so that I can directly access this from the internet. So the application, the database. Application facing to the internet, database hiding and making it private so that it will not be exposed to the internet. Ideally, that's how it is. Any questions so far? Any questions so far?
No. Now we have created a private subnet. We have EC2 instances in it, and suppose this is all in cloud because EC2. Okay, so if it doesn't have a public IP address because we do not have internet gateway connected to it, and how are we going to access those EC2 instances?
Pardon?
We have a private subnet. Okay, so so EC2 instances will not have public IP addresses, right? So how are we going to access those instances?
This one.
If at all any maintenance has to be done, yes.
I'll talk about it. Okay. I'll talk about it. So another point which I wanted to also tell you is I have a application database, and application should be able to talk to the database. Okay, because these instances are in the same network, these instances can communicate with each other using the private IP address. They don't need public IP address, okay, in order to interact with each other. So if I have an application and here, and if I have a database here, my application can talk to the database because they are in the same network. Okay, internal communication can happen within the private IP address within the network. This also I explained you when we are talking about public, private, and elastic IP address in the slides. Okay, so for internal communication, private IP address would be enough. But if I want that instance to access to the outside of the network, which is internet, it needs a public IP address. Okay. Whatever you ask, Samarth, I'll answer that. That's the next step which I would be answering it. But any other questions apart from it? Those who have access can access with private IP address. Yes, correct. So answering your question, for example, now right away, I can connect to the public instance. From public, I can connect to the private instances. Yes, it's possible.
Okay, got it.
Yeah. Connecting to the instance, we can do it. That's not a problem because internally they can communicate with each other. Okay. Now, yeah, yes, that I have an application here. I have a database here. Obviously, if a database is running, there will be new versions of the database will be released. What if I want to upgrade my database or update my database? In order to update or upgrade, I need internet connection. Definitely, I can connect from public instance to the private instance. It's completely, it's possible. But what if this instance needs some internet access? Because if I want to update or upgrade, if I want to update or upgrade, I need what? Internet. That's how I update it, obviously. So what we can do is in that case, let me find another color. Okay, first. So what we can do is we can go for NAT. You need to have, you need to create a NAT in the public subnet and need to add as a route in the private route table. Because the NAT is created in the public subnet, obviously the NAT will have the public IP address. Okay, so that whenever this EC2 instance, okay, whenever this EC2 instance is trying to update or upgrade its database, the private IP address of this instance will translate into the public IP address of the NAT to go to the internet. I repeat, whenever an EC2 instance is requesting something to the internet, the private IP address of the instance will go to the public, will translate into the public IP address of the NAT to go to the internet. Okay. And when the internet is responding, the public IP address of the NAT will translate into the private IP address of the instance to get the response. So the EC2 instance is requesting. When it is requesting, it translates the private IP address to public to go to the internet. And while internet is responding, the public IP address of the NAT will translate it back into private to get the response. Because this is translating the network address, which is from private to public while going and from public to private while coming, this is called network address translator or translation. Okay. Okay. Fine. Now that because of the NAT, thanks to NAT, the EC2 instance in the private subnet also going to the internet. Yes, however it is doing, it's translating public to private and private to public. It is doing some mechanism, but even this instance is able to access the internet, right? But Anupama, this instance is going to access to the internet through internet gateway. This instance is also accessing the internet through NAT gateway or the NAT instance, whatever the NAT. If both the instances are accessing the internet, but what is the difference? Why I need to create a separate route table, calling it as a private? Instead, I can keep this instance here only, right? So that both the instances can access to the internet. How it is different? Or what is the difference between NAT and internet gateway in simple terms? Now let's understand this. Okay. Now, the instance in the public subnet is having internet access. The instance in the private subnet also having internet access, right? Both instances are having the internet access. It is going through NAT. It is going through internet gateway. So what is the difference between two? I want you to clearly understand this, okay? Listen to this carefully. I have an EC2 instance. And this is internet. And this instance is in the public subnet. So this instance will go to the internet through internet gateway. Okay, so what I'm trying to make here is the EC2 instance is accessing the internet through internet gateway. So this instance is in the public subnet. And I have internet. In between, I have internet gateway. Okay, the same way. So the EC2 instance in the public subnet, I'm going to the internet through internet gateway. Okay, now, if EC2 wants something like update or upgrade, whatever, the EC2 will request. It will request. And the internet will respond. Yes, it responds. Okay. There is one more thing where I am trying to access this EC2 instance from internet. Like I have a Facebook application, I say facebook.com. Now from internet, the EC2 instance will get a request. The instance will get, so the internet will send a request. The instance will receive a request. And the instance will respond, yeah, you give me your credentials, kind of response. So these are two different things. In this scenario, the instance is requesting, internet is responding. In this scenario, the internet is requesting, the instance is responding. So they are two different things. Now let's see the same thing in private subnet through NAT. Now the instance is in the private subnet. Now if EC2 wants something through NAT, I can make a request. And the internet will respond. See, I want to update my database. Okay, go ahead. It responds. Okay. Now, if EC2 instance, so from internet, if someone wants to access this EC2 instance, like maybe I have a database here. Okay. From internet, I want to make a request to this EC2 instance. No machine can make a request to this EC2 instance through NAT from internet, where it is possible in internet gateway. So even though both the instances can make a request and get the response, but the EC2 can make a request, but does the EC2 receive the request through the NAT? No, NAT will not allow it. So the EC2 instance can go to the internet to get updates or upgrades, but from outside, no one can make a request to this EC2 instance through NAT. NAT will not allow it. NAT will just roll off. Any questions?
In NAT, you explained saying as NAT will convert private IP to public IP and again public IP to private IP. So when public IP to private IP is converting, then the request has to come from internet to IC2, right? To private network in that case.
Come again?
So for NATing, you explained as it will convert from private IP to public IP. To so again vice versa from public to private IP.
Private.
So for when it's coming from public to private, so the request should come from internet only, right? To NAT. So
correct. The response
the
response will come from internet, not the request.
Okay.
EC2 instance is requesting.
Okay. Only the EC2 request response, it will not request from the direct request from the internet.
The EC2 can request and internet will respond. While responding, it will get it from the internet. It's a response.
If it is through IG, like request is
Through
from
internet gateway only. Yes, through internet gateway only, it will get the response. But see, request response is different. For example, if I initiate a request, you respond it or not, it's up to you. I initiating a request and you initiating a request are the two different things, right? I said hi, you will be saying hi. Okay, but when you say hello, I may or may not respond. So initiating request is the thing which I want you to understand here. That is the reason I explained it this way. EC2 is requesting something, update. Yes, internet is only giving the answer, but it is responding. But explicitly from internet, no one can make a request. It's like this.
Yeah.
It's now that I'm talking to you, you're responding. Now you know what? Now if you try to unmute, can you please try to unmute? You can't. I disabled it. You can't unmute. What I have done? I disabled the response. Now you can again. Can you please try? Yes, everyone is trying it. Good.
Yes.
That's how it is. That's how it is.
Yeah.
So request and response are two different things. We usually think it is, yeah, it's the same. No, it's not. Understood? Any other questions, please?
So Anu, so when a request is submitted, right? So from the private IP to NAT to internet. So the request is first submitted. So the response can be taken back. But whereas from the response from the internet, the request comes from the internet, then you're not allowing it. Is that right?
NAT will not allow it.
Allow
That's
it, right? Okay,
That's right.
got it.
That's right.
Thanks.
So one question regarding the private. Then private IP is only for the read instances or like so you are not allowing internet request in private IP, right? Even NAT is allowing it.
Allow, can you please repeat that again clearly?
Sorry, am I audible now?
So
you're not allowing internet request to the private IP. I mean private
the
subnet.
instance.
Yeah, private instance. So like, so then only the read access is like we can perform only the read permission accesses to the or
No,
like
nothing read write. Any request cannot be initiated from internet to this instance through any means.
Okay. Yeah, just was trying to understand like then what exactly the purpose of private subnet, or maybe.
You're missing from the whole part, Srinidhi, if you're asking this again.
I think it's
If
for
I have a
security purpose.
Facebook, hold on, please. If I have a Facebook application, if I have a database, why I want to access this database? Do I have access to the Facebook database? Do you have, Srinidhi?
No.
No. We do. Is it okay to have a database access
No.
in terms of security?
No.
That's what I am making. From internet, no one can access the to my private instance. Fair enough. Why should I? It should be secure only. It should be private only.
Okay, but like what about the data present if I want to retrieve that data? So
Within the network, you can communicate with each other.
okay.
So I also said that I can connect it from public instance to private instance. They can communicate with each other with using a private IP address, right? Within the same network. Now, private IP address communication means it's secure. It is not outside of the network. Means it is not inter-network. Means no one from outside is not accessing the data. Within the network, and it's happening. So you can manage it. It's
Okay.
like
Yeah.
going to your room, like it's like your home is like a network, and you do have access to different rooms. From one room, you can access because you have access to your whole home. Internal communication can happen. But if you want to go outside communication, then you may need to go for other network. It's another home.
Got it.
Mm. Mm. Shall I move forward? Okay, cool. Now, when you say NAT, in AWS, you have two types of NAT: NAT instance, NAT gateway. When I say NAT instance, it's like a normal EC2 instance only, okay? And another EC2 instance, it's just that it has a NAT software installed. Okay. So I can just launch an EC2 instance and I can just get that NAT packages and I can install it. It becomes a NAT instance. Simple. Like I have an EC2 instance and I have an application in that. It becomes an application instance. Facebook instance. Yes. If I have a Facebook application, it becomes a Facebook instance, right? Same way. If I have an EC2 instance and having an NAT software installed, it becomes a NAT instance. Okay. And we also have NAT gateway, which is managed by AWS. Okay. So we can also go for NAT gateway. We can go where AWS manages this NAT gateway. So we'll understand what is meant by like AWS managed component versus NAT instance, because NAT instance is the instance which you need to manage it, because we are creating from the scratch, like creating an EC2 instance, having a NAT, and you have to take a few more things. I'll explain about it. Whereas in NAT gateway, it is managed. AWS will be taking care of it. So we'll see few examples like what has to be managed by us, what AWS will manage it. But before that, what Sachin? Security gateways are. What do you mean by security gateways?
Ma'am, I just want to know, like, not security gateway, like instance net type of, we are using security groups that you have told previously, type of net, I say, kind of. Am I right, or something like security groups?
You're comparing security groups with NAT. Huh?
Yeah, means security groups can be a part of NAT, I think, as you said.
Security group is a firewall. Okay. Whereas NAT is basically a software or a tool which we install on a server.
Okay.
So, okay. Now coming to the difference between NAT instance and NAT gateway, let's assume I have hundreds of instances in the private subnet. If they wanted to get something from internet, these make some request to the internet through NAT. So if I have hundreds of instances, it makes many requests, and the NAT has to should be able to handle that request, no? So if you're going for a NAT instance, the EC2 instance which you create for NAT must have a supported hardware configuration, which is instance type. So you should be taking care of the instance type of the EC2 instance if you're going for a NAT instance. If I go for T2 micro, which is smaller one, but I have multiple instances making request to the internet through NAT. What if the NAT is not able to handle it? No point. So you should be taking care of the instance type according to the request. You have to increase and decrease, change the hardware configuration accordingly. Whereas NAT gateway, it manages according to the request. The NAT gateway will expand and shrink back automatically. Now coming to the security group. Now the EC2 instance is making a request to the internet through NAT. Now the NAT security group should allow the traffic to the internet. So you have to take care of the security groups also, allowing the traffic to the internet. Whereas in NAT gateway, it is managed again. You did not explicitly mention anything. When you launch an EC2 instance, we get an IP address, public IP address, right? We can also enable that so that IP address will be created. By default, if you enable it, we will get a public IP address. If you want, you can go for elastic IP address, but it's not mandated to have an elastic IP address. To an EC2 instance, you can still work with public IP address. But the NAT gateway demands an elastic IP address. It has to have an elastic IP address. Then only the NAT gateway can be created. But here it's optional. Okay, and we know that the elastic IP address will cost us. For NAT gateway, it will cost you because you are not assigning it to any EC2 instance. So if you're creating it, AWS will cost you. So NAT gateway is chargeable, simple. NAT instance, if you public IP address, there is no cost. Okay, if you choose the free tier limits, for NAT instance, you don't get cost straight away. But for NAT gateway, doesn't matter. By default, AWS will cost you because you're creating an elastic IP address. If you're going for NAT instance, the source and destination check should be disabled if the NAT gateway is managed. Now let's understand what exactly is the source and destination check. Okay. So let's assume I have an EC2. And I'm trying to connect to this EC2 instance from my local mesh. Okay. Now, when I make a request to this EC2 instance, whatever, SH or HTTP, I'm just making a request to this EC2 instance. Now, when I am making a request, the local machine is the source and the EC2 instance is the destination, right? The source making a request, initiating a request, and this is the destination. To this instance, it is making a request. Now, obviously, when EC2 instance is responding, Now, when instance is responding, this becomes a source. And the local machine will become the destination. So EC2 at any point of time, it can be either source or the destination. When it is getting a request, it becomes destination. When it is responding, it becomes a source. Now, when you are going for a NAT instance, it should be disabled. The source and destination check should be disabled. Means the NAT cannot be source or destination. I'll tell you why, how. So when EC2 instance is making a request to the internet, the instance is a source. Does the NAT is a destination? No, the internet is a destination because it has to go to the internet. When internet is responding, it is a source. But does NAT is the destination? Or yeah, it's not a destination. Okay, but does NAT is the source for this EC2 instance? No. Okay, the EC2 is a destination. So the NAT cannot be the source or the destination. I repeat, no problem. Okay, now when EC2 instance is making a request, the instance will become the instance will become the source. The NAT is not the destination, right? Because the instance is actually going to the internet. So the internet is the destination. Now, when internet is responding, the internet will become the source. Okay. And the EC2 will become the destination. Okay. For this EC2 instance, even though it is coming through NAT, but the NAT is not the source also. Who is the source? The internet is the source. Okay. So the NAT is just a mediator. It's like a translator. It just translates the IP address. This is neither the source nor the destination. It is just a translator. Okay. Now, by default, the EC2 instances will assume that is the source or the destination. So when you're going for an EC2 instance and having a NAT on it, okay. So by default, the instance will have that. The instance will assume it. Means by default, the source and destination check is enabled for the EC2 instances. So by default, the EC2 will think that this is the source and or the destination. Means when EC2 instance is requesting something, the NAT, the EC2 instance which has a NAT will think this is the destination, but the NAT has nothing to respond. So the request will just drop here itself. So the instance will not get any response. So in order to forward that request to the internet, you have to explicitly disable that source and destination check. Then only the request can move to the internet, becomes the destination. Okay, so by default, for each EC2 instance, as soon as we create it, it will have that source and destination check as enabled. We have to explicitly disable it. For NAT, no, AWS will be taking care of it because it's a managed one. Okay, so ideally, when we have an application, and if you have an application and the database, ideally you will have this kind of setup in network, like public, private, and private subnet, public subnet, and all. Sometimes you can also have this can be an application servers or application subnet. This can be a database subnet, and you can also have a web subnet, a web server subnet. You can have multiple layers. We can have multiple subnets. Okay, this is basically a simple architecture. Ideally, if I want to have an application on a server or a database on a server, how to create an infrastructure. Okay, so this is basically our project one. Okay, any questions, please?
Sorry, madam, whether I been followed or not, you told or not, I don't know. Just one thing is that EC2 instance means, is that an one more EC2 instance where we'll configure NAT into the EC2 machine?
It's also another EC2 instance.
multiple EC2 instance can configure to that EC2 NAT EC2 instance. Is that right?
Yeah, I can
Multiple
create 10
EC2
EC2 instances, and in all 10 EC2 instances, I can have NAT. Yes.
So in that case, we don't need the NAT gateway itself. So we can do it with the NAT EC2 instance.
Okay. So now let's understand another aspect of NAT gateway and instance. We completely understood that NAT gateway, according to the request, we can expand and shrink back. Okay, so Venu, what you're thinking is instead of having a NAT gateway and paying to AWS, I can have multiple NAT instances and I can have it so that any instance can respond to the internet. I completely agree. But how do you know that how many instances you need it? So definitely you can know it when according to the number of requests, and you have to, you can just create the EC2 instance and you can manage it. Instead of having one instance, you can have a bigger instance type and you can manage that as well. Or you can have two instances. If one fails, I have another one. Yes, you can actually manage that. But the main difference between two is about the managing only. See, in the NAT instance, you have to manage it. The customer has to take care of it. Completely agree. Can't the customer take care? Yes, of course he can take care. He should be monitoring that instance, making sure that everything is fine all the time. Whereas in NAT gateway, the advantage is that AWS will be taking care of it. It expands and shrinks back according to the number of requests, and you will be paying for whatever you are using it. So now let's assume that you have a great architecture where you have a multiple subnets, hundreds of subnets, thousands of instances running and all, where you are going for a NAT instance for that. Okay, where the private instances are accessing through internet to the internet through NAT, and you're managing a NAT instance, taking care of the instance type. So if you can monitor 24/7, making sure that it never goes down or it never becomes a bottleneck. Okay, but if you can't manage it, then you can go for NAT gateway, where AWS will be taking care of it. It is just about the management. Who manages what is different, that's it. But if it is a critical application, do you take chance to monitor it relying on human resources? That is the question. Or do you leave to AWS, where AWS will be taking care of it? Because when you're going for a great architecture, having like a lot of instances and it's a critical application, if you go for NAT instance, it can become a bottleneck because it has limitations. If you go for NAT gateway, it expands. Yes, understood. Yes or no?
Yeah, understood. Ma'am. Thank you.
Guys, because you are understanding, so you don't have any questions, or you are not understanding, so you don't have any questions?
Anu, can you give just quick again one more time between the instance and the gateway? Quick recap.
Okay, what you understood, Priya? Let me come with you.
So from the instance where we have some limited limitations, so where of the usage, right? If anything to be maintained, like the IP address, like public and the elastic IP address.
Okay, no problem. Anyone can explain about NAT instance and gateway, how it is different and how we can see them? Anyone who think that they can answer? They can explain about this options again. Anyone? I can help, of course, in between.
In NAT instance, like we need to manage the hardware, and in NAT gateway, AWS will manage it.
The hardware configuration, which is instance type, absolutely. Next.
And
Secure.
Okay, security group. Yeah, right. Security group, whatever like blocking of public, I mean source and destination, it needs to be done by manual from our end. and in NAT gateway, AWS will manage it.
Exactly. So when instance are making a request to the internet, in the security group of the NAT instance, we should allow it. Then only it can go forward to the internet. So that has to be done by us. In the NAT instance, it is managed in NAT gateway. Okay. And then?
And public IP and elastic pool IP. That's all also we need to manage it in a NAT instance. If we go to the AWS, it will manage by, it will.
No. Okay. So what exactly happens is in NAT instance, we can create a public IP address. If you want, we can have elastic IP address, but there will be no cost associated with it. Okay. By default, when you launch an instance, public IP address will be assigned if you enable it, and there will be no cost. Even if I go for elastic IP address, and if I don't stop it, elastic IP address doesn't cost us. But for the NAT gateway, it needs an elastic IP address. Public IP address will not be assigned to a NAT gateway. It has to have an elastic IP address where it will cost us. So it is chargeable.
Yeah.
Then?
Source and destination disable.
Exactly. The source and destination check has to be disabled for the NAT instance where it is managed for the NAT gateway.
And NAT gateway, AWS will manage it.
Yeah, exactly. Okay, Priya?
Yes, Anu. Yeah, got it. Thank you. Thank you for explaining it.
Yeah, correct. If you don't have any questions, now we'll try to implement this in the console. And rest of the time, I'll give it to you for the hands-on. So whatever the time, I think you'll get around 2 hours to do this hands-on in the class. So what I suggest is, please don't do with me. You do it once it is done. You struggle and do it. In that way, you will learn a lot. If you do with me, you will not learn anything. It's up to you again. Okay. So let me just try to implement it in the console. So I'm in AWS management console. Okay. So however, I explained the same way I'll create the components also. Okay. In AWS in North Virginia region, we'll create a VPC. So in AWS in North Virginia region, let me go to VPC. And I'll create a VPC with this CIDR. Creating the components is easy. Okay. The good thing is they're easy only. Okay. So let me go to create a VPC. See, as I said, there is already a VPC which is created by AWS. You see, a VPC is already there. So please don't touch the VPC and the VPC components at all. The default ones I'm talking about. Okay. Now let me just go and create a VPC, which is custom VPC. I'm naming it as custom VPC. And I'm giving the CIDR 10.0.0.0/16. Okay. I'm not going for any IPv6. And I'm just creating a VPC. That's it. Giving a name, giving a CIDR, like I did here. Okay. Now, once we create a VPC, we need to create subnets. Yeah. So I'll create 2 subnets, public and private. I'll give the same name and I'll create with 2 different CIDRs. Okay. In the left navigation, again, we have subnets. And I also have subnets of the default VPC. Okay. So I'll just ignore them. So these are the subnets of default VPC. So let me create a subnet for my custom VPC, the one which I have explicitly created. You see the importance of tags. Now I'll create 2 subnets. One is a public subnet. Okay. And I can choose the availability zone as 1A for this subnet. And I'll give the CIDR .0/24. Okay. And I'm also adding another subnet for private. So I'm creating a private subnet. Yeah. It's in 1B. And I can give a CIDR 2.0/24. Okay. And create it. So what I'm doing is, in the VPC which I have created, I'm creating 2 subnetworks with the respective CIDRs. Okay. And I'm creating these subnets in 2 different availability zones. So VPC span all availability zones in the region. Okay. Now I wanted it didn't show you before, just not to overwhelm you with all the square boxes. So we can create a subnet in one way. I explicitly highlighted this with this color just to see that, but not in a dark mode. Okay. So this can be in 1B. Okay. So I've created two subnets in two different availability zones. Now, once we create a subnet, to get the internet access, we need to create an internet gateway. You see, we will work on these components only 1, 2, 3, 4. So even when you're doing the hands-on, you just need to work on these 4. So don't worry about creating with me. Please just look into it, concentrate. Okay, see how I'm creating. Next is creating an internet gateway for the VPC which we have created. So create an internet gateway. Give a name, a custom internet gateway, and create it. That's it. You see, I just created, but I haven't, specifically mentioned any VPC. So I need to explicitly attach it to VPC. Okay. So in internet gateway, you need to create it and you need to attach it. Means creating it and attaching to this VPC. Okay. Now, once I create an internet gateway, it doesn't mean that the instances will have internet access. It has to be routed with the help of route tables. So first of all, I'll create the route tables. Then we will see this connection part, routing part. Okay. So let me go to route tables. Create a route table. I will call it as a public route table. And I'll select the VPC which we have created. That's it. Giving a name and creating, selecting the VPC, that's it. Okay. And at the same way, I'll also create another route table. I have created a public route table. I'll create private route table. Select the VPC which we have created, custom VPC, and create it. You see, now what we did, we just created the components. Now we'll see this association, adding the route and all. Okay. Now what we will do is, we will add this internet gateway as a route in the route table, and we will associate this subnet under this route table. So we will do this part. Okay. And because we don't have NAT now, we will just add the subnet under this route table, the private route table. So we will do this NAT later, probably at the end. Okay. So for now, we will create two route tables. We have created two route tables, right? We will add this internet gateway as a route in the public route table, and we will associate this public subnet under the route table. So these two things will be done in the route table only. So go to route tables, select the public route table, go to routes, okay, edit routes, and add a route. So here under the target, you need to select internet gateway. Because we have created internet gateway, you will see that the internet gateway is the option. You can select it, and this has to go to the internet. So what we are doing is, for the route table, the target is internet gateway, where it is going to the internet. Okay. So target, destination is internet. All zeros means internet. I'm saving it. Now, second thing is adding the subnet under this route table. Okay. So let's go to route table again. Go to route table. Select the public route table. Select the public route table. Go to subnet associations. Edit subnet association. See, routes is internet gateway here. Subnet associations are here. That's it. You need not worry about much. So select the public subnet and save it. So I could see two subnets. Now I selected the public subnet and associated under the public route table. So this association part completely done. I made a path. Now for the private route table, I will just associate the private subnet under the private route table. This NAT we'll do later. Okay. So click on the private route table. Go to subnet association straight away. Edit subnet associations. Select private subnet now. Save it. Now the VPC setup is almost done. We created VPC.
One second. Your action and the voice is not syncing. Some delay is there. So something are missing when you are showing that. So
Is
I
it same
don't know,
for
it's
everyone?
only for me.
No, it's fine for me.
Okay, so Beno, I think you have some internet issue. Its video is delaying. Yeah, it's fine for many people. Okay. So what I'm saying, yeah. So for the route tables, yes, we have associated well. Now we have created almost all the components, like we created VPC, subnets, internet gateway, route tables. Association part is also done. Now I also wanted to show you one more thing. Now, the public IP address assignment for the public subnet. See, whenever I launch an EC2 instance, I wanted to get a public IP address for this instance automatically. If I wanted to get in that way, I can enable that in the subnet. So I can go to subnets. I can go to public subnet, go to actions, edit subnet settings, enable auto assign public IPv4 address. So what it does is, as soon as I launch some instances, whatever I launch in the subnet, it automatically assigns a public IP address to that instance. So I'm enabling it so that I need not explicitly enable it at each instance level. It's an optional step. I usually prefer doing that. Okay. Because I can explicitly enable it at each instance also. So when I'm launching an instance also, I can enable the public IP address, but I need to do it at every instance if I create, which I create. So just to avoid it, I can enable the subnet so that all the instances if I create in the public subnet will have a public IP address. Now the VPC setup is done. Now what we will do is, we will launch two instances in two different subnets in the custom VPC. I'll show you how to do it. Yeah. So now I'll just duplicate my tab, because this tab I'll work on EC2 and this tab, VPC, and this tab I'll work on EC2. Okay. I also request you to do the same so that you can, when you're navigating, you will not be wasting time going to the services, getting confused. By the time you go to the service, you may forget what you want to do as also. So just open two tabs, the best practice. Okay. And let me just launch two instances in two different subnets in the custom VPC. I'll show you. In fact, we created the EC2 instance without knowing VPC only. Correct? We created EC2 instance multiple times in a default VPC. Okay. Now what we are doing is, we are creating an EC2 instance in custom VPC. Okay. So now, which instance? A public instance. So it's public instance. I'm creating in public sub. Okay. I'm just naming it as public instance. I will choose Ubuntu. As usual, Ubuntu. Ubuntu T2 Micro. Of course, I need key pair. I will use the existing key pair which is named as public for public instance. Now in the network settings, I will edit now. Now it makes a lot of sense. So far, whatever we created in the VPC which is already there. Now we will create in the custom VPC, the one which we have just created. Okay, and we will have two subnets, public and private subnets, which created in 1A and 1B. I will create an instance in public subnet now, later in private subnet. And you see, I selected the public subnet, and the auto assign public IP address is enabled by default, which I just enabled in the subnet setting, right? But if I select the private subnet, it is disabled, you see. Okay. So automatically public IP address will be assigned to the instance. Security group, I need SH. I think I'm good with the root volume. I launch an instance.
So I know here when we select the VPC, right? So the subnet will automatically show up what are in that particular VPC which we have added.
Correct, ma'am. Because
VPC
is a network. VPC is a network. When you select a particular network, the subnetworks within that will also show. Getting me?
Okay. Yeah, got it. Thank
you. So private instance. Okay. And I will choose Ubuntu for that. Same. And T2 micro. Key pair, because the private instance, I'm choosing an existing key pair which is private. It is just a naming convention, guys. When I say public, it doesn't mean that the key pair is public. When I say private, it's not like that. Okay, I'm just giving a name it as a public and private just to show you the differentiation between the key pairs for public instance and private instance. Okay, you can give whatever the name you want it. Okay. Now this time I will create in the private subnet. Okay, where I'll not have any public IP address for the private subnets. I'll open SSH protocol. The same, I'll stick with the root volume and I'll launch an instance. Now I have 2 instances in 2 different subnets. See, now we are progressing nicely. Okay. So now, before I actually go to next step, let me show you a few things. Now, if I just select the public instance, the public instance is having public IP address, where the private instance shouldn't be having it. It is not there. Next point. Now, if I select the public instance again, you see the private IP address of the public instance. It is having 10.0.1.239. As I just explained previously before, in the whiteboard, all the instances in the public subnet will start with 10.0.1 because it is /24.888. So this is subnetwork prefix. So the instance which is in the public subnet is having 10.0.1. It took some number. Doesn't matter for us. Now you see the private instance, the private IP address 10.0.2.93. 10.0.2 is the subnetwork prefix for the private subnet because again it's a /24.888.824. And it took some number again. It took 93. Okay, it randomly picks some IP address, but of course within that range only. Okay, so you can also check this way whether you have created correctly or not. Did I create in public subnet? How do I know? One way is checking the IP address, private IP address of these instances. Okay. Now that we launched 2 EC2 instances, perfect. Now, before I actually have a NAT, let's try to do the second part of this project, like connecting to these instances. Okay. So tell me, guys, if you want to connect to an EC2 instance, can we use same keys for both EC2 instances? Yes, we can. We can use same, we can use different. Doesn't matter at all, actually. Okay. Now tell me, guys, if you want to connect to an EC2 instance, what is required? Like, let's assume that you haven't attended this session. Now, keeping the last week's knowledge in mind, if you want to connect to an EC2 instance, what is required?
Public IP.
EC2 instance should have public IP and the SSH port should be open.
Okay, perfect. And that's it. Key pair. Yogendra. We need to have a public IP address of the instance. The SSH protocol must open and the key pair, we should have it. You cannot connect to my instance, correct? Even if I'm showing my public IP address here, will you be able to connect to my instance? No. Why? Even though SSH protocol is open for my EC2 instance, which you know now, you cannot connect it. Why? Because the keeper of this instance is with me. Only I can connect it. So please understand here, okay? I want you to understand a few things, okay? If I want to connect to an EC2 instance, that instance IP address, public instance must have a public IP address. The instance keeper should be there in the local machine. Okay, now, this is the public instance. The public instance is having a public IP address. It is having SSH protocol. And the instance PEM file is in the local machine. I have chosen existing keeper, right? That means it's in my local machine. Now tell me, guys, because these are all possible, it's all there. Will I be able to connect from my local machine to this EC2 instance? Yes or no?
Yes.
Yes, of course, yes,
Yes.
because yes, I have the instance IP address, public IP address, the SSH protocol open, I have the PEM file. I can connect from my local machine to this EC2 instance. Yes, it's possible. Now, if you see here, the second instance, the private instance, will I be able to connect? So this private instance PEM file is also in the local machine. It is there, yes, because I have chosen existing key pair. I have this in my local machine also. This also in my local machine. Now, will I be able to connect from my local machine to the private instance?
No.
Why?
No,
Why?
it's not connected to network internet.
It's not.
Public.
Okay.
It is
Public IP
private.
address is
Public
also
IP
not
is
there.
not. Yeah.
Public IP address is also not there, and also it is not having internet gateway as a route in this route table, right? So I cannot connect it. Correct, no? See, even if I have public IP address, let's assume, please understand, I wanted you to understand different combinations. Let's assume I have a public IP address for this. Okay, so even if I have a public IP address for this instance, will I be able to connect from my local machine to this instance?
No.
Why?
No, internet
Route
gateway.
table
is
not
there.
mapped to
Internet
IP.
gateway is not there in the route table. So even if I have public IP address, I cannot connect it. Okay. Now let's assume that I have NAT. Assume it I have NAT. I have created NAT. I have added this as in the route table. After that, will I be able to connect from my local machine to the EC2 instance?
No, but yes with NAT IP.
Even if I have public IP address?
No.
Why?
That is, we won't get full request to the
Exactly.
responsibility.
Even if I have the PEM file, the public IP address, the security group, my local machine cannot connect to this EC2 instance through NAT. NAT will not allow. So even if I have all these details, I cannot connect it. So whatever I do, I cannot connect to the private instance. You agree? Yes.
Yes.
Now, yes, I completely agree that from local machine, I cannot connect to the private instance. But will I be able to connect from my local machine to the public instance, and from public I can connect to the private? Is it possible using private IP address from here to here? Yes or no?
Yes, it's possible.
Yes. As I said
with
again,
NAT, yeah.
exactly. As I said earlier, I can connect from my from one instance to another instance using private IP address within the network. Within the network, I can connect it. That's what we discussed. As I said earlier, definitely I cannot connect from my local machine to the private instance, but I can connect from my local machine to the public instance. From public, I can connect to the private instance. Possible? Yes.
Yes.
Yes, that does not need NAT or anything, because by default, with the private IP address, I can connect it. So we'll do this. Not what we will do. We'll connect from our local machine to the public instance. From public, we'll try to connect to the private. That's the whole part. And that will be the end of this class also. I mean, this lab session also. Okay, we will do that. But to do that, of course, I'm sorry, there's another step which we'll be doing it, but that would be our ultimate step. Okay, now, if I want to connect from my local machine to the public instance, we understood that the instance IP address, public IP address should be there with us. Instance must have security group which has SSH protocol open, and the PEM file should be there in the local machine, so that from my local machine, I can connect to the public instance. But please understand, if I want to connect from public instance to the private instance, okay, the private instance must have a private IP address, because internally, the private instance security group must have SSH protocol. And finally, what? The private instance PEM file must be there in the public instance. Then only I can connect it. Of course, yes or no?
Repeat it again, please.
If I am connecting from my local machine to an EC2 instance, the local machine should have the PEM file.
Right.
If I am connecting from public instance to private instance, this instance must have the PEM file of this instance. Then only I can connect it. Yes or no? Agree? Hello?
Yes.
But where is my PEM file? Is it in the public instance? No. The private instance PEM file is also in the local machine. So what I need to do firstly, I need to copy this PEM file into the public instance before I connect to the private instance. Yes or no? Yes.
Anupama, sorry, just for my understand. So EC2, private.
Hold on. Public instance, private instance. Go ahead.
Okay, private instance PEM file needs to be in the public instance, right? You are trying.
Correct.
Okay, fine.
Yes, yes, yes. So when you are connecting from a machine to an EC2 instance, it can be EC2, it can be local machine, doesn't matter. Okay. If I am connecting from a machine to an EC2 instance, that EC2 instance PEM file should be there in that machine. Simple. Okay. Now the private instance PEM file should be there in the public instance. But where is my PEM file? It is also in my local machine. So what I will be doing is, first step is I'll connect from local machine to the public instance. Then I will give permissions. The third step is I will give permissions so that I can copy this PEM file to this instance. Okay. Third step is giving the permissions to this instance. So what I will do, I will give permissions to a folder in this instance so that I can copy that into that folder. So third step is giving the permissions. Then I will exit back to my local machine. Okay. And then I will copy this. See, I should be in the local machine, right? To copy. I should be in the source where I have the PEM file. So I'll go back to my local machine and I will copy it. Once I copy, I'll connect back. Now this PEM file will reflect here, the private instance PEM file. So once I could see the PEM file of the private instance, I can connect from public to private. Sixth step. Understood? Yes, no, maybe?
Yes.
I repeat, okay? First of all, I'll connect from my local machine to the instance. I will give permissions. I will go back to my local machine and I'll copy this PEM file into the instance. I will run a command to copy it. And I'll come back to this instance and check whether that PEM file is reflecting in my instance or not. And from public instance, I'll connect to the private instance.
Okay.
Any questions?
No.
Let me go to the folder where I have my PEM file and I'll share back again, okay? So don't worry if you're not understanding it at first stretch. Obviously, it's a complex topic. That is the reason I named it as a project 1. Okay. This you need you need to go to the recording once again if you are little aware of VPC, twice if you are completely new to VPC, thrice if you are new to IT only. Okay. You'll understand, okay, once you go again and again, definitely you'll understand. It's not a rocket science. Okay. If I understood, you can also understand. Okay. Anyways, let me share my screen again. So I have this folder where I have my, sorry, 1 second. Have my PEM file. Okay. So I will go to Git bash. Yeah, let me explain it. Now what I will do, first step is from my local machine, I'll connect to this instance. So chmod 400. So I also wanted to show you that I have this PEM file, both the PEM files in my local machine only in the keeper folder. Keeper folder. Okay, I've changed the permissions and I'm connecting to this instance from my local machine, taking the public IP address. Okay. The next thing is there is a mandate command, no? Sudo apt-get update. Let's do that first before I do any operations. Okay. Now let it update. Now what we will do is we will give permissions to a folder in this EC2 instance. Okay. So it's still updating. Give me a moment, please. So what I'll do is I will say chmod read, write, execute permissions to everyone to the OPT folder. So it is not giving permissions because I'm an Ubuntu user. Let me elevate myself into sudo su. Okay. and give these permissions now. It should allow now. See, I'm giving read write permissions to the user, group, and to everyone. I'm giving permissions to only OPT folder so that I can copy this PEM file into the OPT folder. I'm not giving permissions to everything in this instance. No. Okay. I'm giving only to the OPT folder. Now, if I check what I have it in the OPT folder, okay, I don't have anything. When I say ls, it will list no. If I have any files, I don't have anything now. I have nothing. Okay. Now what I'll do, I will copy the PEM file. Now what I did, I connected to this instance. I've given the permissions. I'll go back to the local machine and I'll copy this. Okay, one by one. So how do I go back to local machine? Exit from root to Ubuntu. Exit from Ubuntu to my local machine. My key pair is my local folder, right? This is my local folder. Okay. Now how do I copy? So there is a command. I'll explain it first. Let me give that command completely just to avoid mistakes. Okay. Perfect. Super. Now what I'm doing is SCP, secure copy. Okay. I am copying the private instance PEM file into the OPT folder by giving public instance details. Okay. So if you want to transfer something, if you want to copy something to a particular, for example, an EC2 instance, you have to have the instance details, right? Like the PEM file and the public IP address. So what I'm doing is I am copying the private PEM file into the OPT folder of the public instance by giving public instance details. If I want to transfer from my bank to your bank, transfer some amount. Before I transfer, first of all, I need to connect with my credentials. And then I can transfer. So you have to know your credentials before you transfer, right? So I have to mention my credentials before I transfer the PEM file into the OPT folder. Now I think it should make a lot of sense why I have created two PEM files with different names. If I give same, now you'll get confused, right? Even if I give different names also, you'll get confused. What if I say, this is a 17th June and this is 18th May? It doesn't make any sense. Now, if I just say public PEM file, okay, it's a public instance PEM file. This is private instance PEM file. That is the reason I have given different names explicitly with public and private. They are just names, okay? Now that I copied, let me connect and see if it is visible in the OPT folder. So now I connected back to the public instance. I go to OPT folder and I say ls. You see, now the private PEM file is successfully copied, and you can also confirm it, okay, by seeing this 100%. So when you run this SCP command, it should be saying 100% successfully copied. So if it is throwing some other error, that means it hasn't copied. Now that, okay, perfect. Now that we copied and then we connected to the public instance. Now the PEM file is in the PEM file is in the public instance. Now I can connect from public instance to private instance using the private IP address of the private instance. Let me do that. Okay. Now, before that, I also wanted to show you, I am in public instance, right? I'm in public instance. Okay. So I am trying to update it. When I try to update it, worked, right? Even I'm trying to ping google.com, means I'm trying to access the internet. It's still working. See? So that means the public instance is able to access to the internet. Yes. Now, when I connect from public instance to private instance, both the EC2 instances, both are Ubuntu. How do I differentiate whether I am in public or private? Let me show you how we can differentiate. Now you see the public instance. Yeah, public instance, private IP address 10.0.1.239. Now I have connected to the public instance, right? Now you see this IP address 10.0.1.239. This is the instance of private IP address. Now, when I connect from public instance to private instance, I will see this IP address here. So you can easily differentiate whether you are in the public instance or in the private instance. Let me connect and show you. Yeah. So chmod. So I have my PEM file. I mean the same command chmod 400 the PEM file ssh-i the PEM file Ubuntu @ instead of public we give private. That's it. Because it's up within the network. Okay. It's asking, are you sure? Yes, I am. And if it connects, you see, I could see the private instance, a private IP address 10.0.2.93. And here I see 10.0.1.239. That means this is the public instance. Now I connect it to the private instance. Clear? Are any questions, please? Okay. Now that I am in the private instance. Yeah. Now, will I be able to connect to the internet? Hello? Yes or no?
No.
Will I be able to?
No. We won't be able to.
Yes. So I cannot connect to the internet from my private instance. I will not be able to reach to the internet because I don't have internet gateway or I don't have NAT also. The request will drop here itself. See, it just hangs up. It will not go anywhere. Okay. Now what we will do, we'll try to create a NAT instance. NAT gateway will cost us, as I said. We'll try to create a NAT instance taking care of all these things. We will add this NAT as a route in the private route table, and then we will ping again. It should work at that time. Now we are creating NAT at the right time. Okay. Now that we understood that there is no transmission happened, 0 received. Okay. So there is no internet. It is not internet. The instance is not connected to the internet. I'll create a NAT and I'll do necessary things, and the instance should connect to the internet. Okay. So let me launch an instance. You know what I'll do? I will name it as NAT instance, first of all. I'll browse more AMIs. I'll go to community AMIs and I'll search for NAT. I'm not installing any NAT explicitly, but I'm searching for NAT in the community AMIs. Okay. And I will choose the very first one. Okay. It has NAT. I'll select the very first one. Okay. And so now that it becomes a NAT instance. Now instance type, I'll go for T2 micro only because it's under free tier and I have only one instance. So T2 micro. Keypair, I don't need it because I don't need to connect to it. And where I need to create this NAT? In the public subnet, right? So select the custom VPC, select the public subnet. And what I need to have in the security group, I need to open everything to access to go to the internet. Okay, so I'll open. Why we are choosing in the community AMI, Shrikant, because we don't want to explicitly waste time on installing the NAT again. Okay, so we are just going for a ready-made solution. Okay, so we are just I'm just opening all traffic. Yeah, so that the request coming from the instance will direct to the internet. I'm opening all traffic in the security group. And public IP address will automatically assign. Enable a public IP address is auto assign public IP address is enabled. So public IP address is there, and source and destination check will be done at the end. Okay. Am I not audible, guys? Do you have any problem with my audio?
No, you are audible.
I'm audible. Ganesh, I think a problem is with you. Now I'm launching my instance with this. Okay. So now that I have launched an instance, launched a NAT instance, taking care of these things, and I'll disable the source and destination check, select the instance, go to actions, instance settings. No, networking. So change source and destination check and disable it. So stop to allow your instances and traffic when the source and destination is not itself. So NAT is not the source or the destination, right? So I'm just stopping it and I'm saving it. So we have taken necessary things for the NAT instance, right? So the last thing which we need to do is we need to add this NAT as a route in the route table. Then only the instance when it is making a request can go through NAT. So what I'll do, I'll go to VPC, I'll go to route table. This time I'll select the private route table, go to routes, edit routes, add a route. Here I'll choose instance because we are going for an EC2 instance, right? So we will see all the instances. You see the importance of tags again. So I have given NAT instance. I select this right away and I'll destination is internet and I'll save it. Now if I think it should work, okay. Otherwise I need to troubleshoot. See, it's working. It's immediate. Just before it didn't, right? Just hanged up there. Now it is. Now the EC2 instance, when I pinged google.com, it is going through the NAT to the internet. Hence proved. Any questions? Any questions, please?
Anu, once the NAT is created, like instance is launched, you're going to the private instance, then we are changing the settings.
Private route table, ma. Private route table in the routes. Yes.
Okay.
Yes. So guys, it's a lot of terminology, lot of new words and how to set up and all. It's completely new. I'm not expecting you to understand this at one stretch. Okay. So if you are understanding, but somewhere you are thinking that you have not understood, it's absolutely fine. It's very common. Okay. So you're not an exception. It's absolutely fine like that. Okay. Because this topic itself is something like this. So don't worry. Please go to the recording again. You will understand it at the second step, second iteration, when you just go to the recording again. Okay, because you have already seen these words. Now again, when you listen to them, you will understand a different perspective again. Understand a different perspective. Okay, so try to do it. Try to do the hands-on, and then if you're stuck, of course, I'm there to support you. Yeah. So before I actually give a break and then allow you to do it, create the breakout rooms, etc., I'll show you how to go for cleanup. And cleanup is very simple. First thing is you need to terminate your instances. Select the instances, terminate. Because before you delete the VPC, first of all, there are dependencies. Instances are the dependencies depending on the VPC, on the network. So you have to first of all delete the servers if you have any. So without that, if you try to delete the VPC, see, they're still terminating, no? They are not still terminating. Okay. So if I try to delete it, it will throw an error. It says that it has instances, so you cannot delete it. Okay. So I have to wait for the instances to be terminated. Then only I can delete it. Now, they are terminating. Okay. Now, another thing is, if I delete the VPC, all the components which I have created also will be deleted. So don't worry about deleting them explicitly. Easy. I did VPC, it will delete subnets, it will delete route tables, delete internet gateway, everything, whatever related to VPC. So that is the reason I said it's very easy. Okay. Now the instances are terminated. Select the VPC, actions, and delete the VPC. Now, I want to explicitly say that please don't touch the default VPC components. Now, when I say default VPC, not only the VPC, don't touch the subnets, don't touch the route table, don't touch the internet gateway. See, please don't touch the default VPC components. Okay, so what happens? Simple. See, because this is today's a VPC session, I'm explaining about how to create a VPC, but the hands-on which we do going forward, we will do all in default VPC only. Now, if you delete any of the component, your VPC will not work as it should be. Simple. Okay, where that hands-on will become difficult for you to complete it. So please don't touch, don't delete them, edit them, change anything in the default VPC components. Okay, if you have done that, if you do that, just let me know. I'll try to correct it. Yeah. So that's it. Any questions before I give you a break? No, I'm not adding anything into your brain now. That's it for today. You just need to practice it, as I said. But in that, if you have any questions, let me know, please. Okay, so after the break, I'll create a breakout rooms, and you guys can work together as usually, whatever the time you have it. I'll close the call exactly at 11:30. I need to, no option. Okay, so I'll close the call at 11:30. Before that, if you have any questions, you can just call me. Don't please stuck in a particular step and then struggle there for more than 5 to 10 minutes. Okay. So if you're stuck somewhere, just check with your room members and then straight away ask me if they are not able to help you, because that's a new for them as well. Okay. But you need to follow the Google Drive document. Okay. For each and every step, please don't call me. I'm explicitly saying this. For each and every step, you are not supposed to call me, and then you are not showing me, ma'am, after this word, this is the one. No, after this, can I go for next step? No, not like that. I want you to do it following the Google Drive steps. Okay. Whatever the document which is saying is. Yeah. If you are stuck and if you don't know where the option is, then you call me. I will not encourage step-by-step guidance. Okay. I mean, the only thing, if you're not understanding anything, is going through the recording. Cool. Thanks for understanding. Yeah. Shall I open the timer then? Yeah. What if someone is talking to you and they are not, you're asking something to someone and they're not responding? How do you feel? I'm feeling the same thing. We have almost 25 plus participants in my class. What's
I'm
wrong?
talking about Nat, we have all become like Nats only.
You all became?
We are all turning into Nats. No response from internet.
You are cool.
Anu, just we are going for a break now, right? Then only you're opening the record.
What ma? What is it?
Anu, are you opening the
timer? Yes.
Timer, right? So, okay.
Yes. Now, yes. What I'm doing is, while I'm talking to you, I'm just giving that whatever the. 1 second, please. Whatever I explain in the whiteboard, I'm just copying that into the WhatsApp group so that you can open the WhatsApp group and then you can see if you have any questions, or if you're stuck somewhere, you can just, this picture can help you. Okay. So I just pasted in the WhatsApp group also. Please refer that when you're doing the hands-on if you think it's required. Okay. So let me open the timer. Happy break, guys. In WhatsApp link doesn't exist, ma'am, please. Ganesh. Guys, someone please paste the WhatsApp link here. He will join. Okay. Guys who are not, please join here. Please join through that link. I don't have any WhatsApp link with me. No. Yeah. Yeah. Thank you. Happy break, guys. Hello, is everyone back?
Thank you.
Here, here.
Okay, cool. So let me create the Paxkart room so you guys can start working on it. Please refer the Google Drive link. Okay, so in that you'll find project 1 VPC. In the WhatsApp, I have shared the the one which I explained. Okay, so you can refer both and you can start doing the hands-on. And if you're stuck somewhere, please feel to call me, yeah, for help, and I can fix it. Okay, so make sure, like, try to complete it. Anyways, I'll be closing the call as per the schedule. But if you wanted to extend, it's fine. Off the call. Okay, so let me open the rooms, and please do join. Santosh, in which room you are into? You want to share your screen here itself? Santosh, can you hear me? Santosh? You're on mute if you're talking.
Hello,
Yeah, Santosh.
I'll share my screen here only. Sharing my screen.
Yeah, share your screen and give me the control. Give me the control, Santosh. Thank you. So you need to share your whole screen, Santosh. I have told this multiple times. If you share one screen, how can I fix it? How can I check whether it's you're pinging, you're able to ping or not? Stop sharing and
Okay.
yeah, stop sharing and then share your whole screen.
Yeah, I'll do that. Share screen. Okay. Screen share. What about now, ma'am?
Yeah, perfect. So where are the instances? Okay, 1 second, please. So give me the control now again. So you're not able to ping. So
Yeah,
this is the git bash. So when you say ping, it's just hanging up there. Okay.
Yep.
1 second. So let me check whether you have opened all traffic for the security group. You opened up. Okay. So let me also check whether you have stopped this. Okay. The last thing is
routing table. Could you check?
So routes.
Edit routes.
You also, this is wrong to the internet. Okay. So now check. It's not at working. That means we need to check few more things. So let me also cross check your route table because you might, let me select this instance, select NAT and save it and check. It's not working. Not a problem. Let me go to instances, select the instance. It is, have you selected the instance type AMI as the NAT? Okay. Everything looks good. Let me check if you have touched the outbound roads. You haven't. So you opened all traffic and again, I could see you made it as custom. It should be anywhere. You have changed a lot of things which shouldn't be. See, it's working.
Okay.
Okay, I'll stop
So
participation.
what was missing? Only the inbound rules, na?
No, right?
Only inbound rules we changed, right?
No. In the route table also you have kept as a /16 CIDR.
Okay.
Okay, it has to be internet. Okay.
Okay. Thank you.
Yeah. So please do the cleanup and terminate the instances, delete the VPC, and I don't teach any other session, any other topics now. If you are done, you can leave for today.
Okay. Thank you, ma'am.
Yeah.
Thanks, Anu. Bye-bye.
Hey, yeah. Yeah, Samad. Chalo, bye. Hey guys, is everyone done? Any questions, please?
It's done, Anupam.
Okay, have you
I
done the
did
cleanup?
that. Not yet. I'll just do that.
Okay, so guys, please do the cleanup. If not
Yeah.
yet done. If you have any questions, you can check with me now. Otherwise, I'll be closing the call.
Okay. Anupam, I have a question, but
Yes,
not
please.
related to this. So, just and is there any thing like related to the Azure also will be having any kind of introductory or something at the last?
Did the StarGel team has said that?
Actually, they said like there will be a recorded session will be available, some kind of.
Of Azure?
Yes.
Okay, so I'm not sure about this. In fact,
Okay.
yeah.
I think probably I have to check with them itself.
Yes, please. Yes, please. If they have told, then definitely it will be there. Okay. You can just check the with the on the same. Okay.
Okay. Yeah. And sorry, one more thing. One more question. So how it will be similar in case like if I have some hands-on with this and easily I can relate to Azure as well.
Yes. So I would compare this Azure and AWS with your Flipkart and Amazon shopping. So if you know how to shop in Amazon app, is it okay if you can shop? I mean, do you feel comfortable shopping in Flipkart? Exactly.
Yes.
So both are e-commerce website, right? So the same way, Azure and AWS are both are cloud service providers. It is just that they're giving the same concept is same, right? They're giving service to others. It is just that the terminology is different, you know.
Terminology.
So probably in AWS we call it as an S3. In Azure we call it as a blob. In AWS we call it as an EC2 instance. There they directly call it as a virtual machine.
Virtual machine. Yes.
Okay. So the terminology will be different. And the features they may say in a different way, but ultimately you can easily understand it. It is not that see, I know AWS, now I can straight away write the Azure exam. You can't, of course. Okay. So but it is easy to learn, easy to understand, and if you are very much comfortable with AWS, you can straight away, even in your project, if they're asking if they're using Azure, it's absolutely fine. You can easily accommodate there.
Okay.
That way. Okay.
Thanks, Anupam.
Thank you. Yeah. Anything else?
No.
Okay. Okay, guys. Thank you so much for joining. See you tomorrow. Yep.
Thank you.
Yep. Bye.
Bye.